Good morning to all of you. In the lecture in which we discussed about evolution of universe, galaxies, solar system, only two topics were left in that video. One was origin of Earth, evolution of Earth. Evolution of Earth. It has two parts. One is evolution of lithosphere. What do you mean by lithosphere? Lith means rock, means the rock surface. The crust, you can say. The rocky crust, the solid surface is called lithosphere. How it evolved. And second, evolution of atmosphere. And hydrosphere. So as we can see now, roughly the atmosphere of Earth composed 78% of nitrogen and around 21% of oxygen approximately. But it was not always so. In initial phase, the Earth was hot, barren. Barren means banjar, without any vegetation. Rocky. Atmosphere was there, but that atmosphere was very thin. Thin. Atmosphere. And in this thin atmosphere, the dominant gases were hydrogen and helium. Okay. So we all know Earth has a layered structure. We have crust, mantle, core, but in the initial phases, in primordial stage, Earth was very volatile in nature. What do you understand by volatile? Means very proactive. There were so many changes going on. Understood? So in primordial stage, Earth was very volatile in nature. So due to gradual increase in density, the temperature inside the surface was also increasing. And due to that increase in temperature, the material inside, or we can say underground, started getting separating in layered form according to their density. Gradual increase in density. Okay, is there a picture in your mind about density? Why increase in density increases temperature? Density means more the particles are closer to each other, more the density. Between honey and water, which is more dense? Honey is more dense because it is more viscous. So if the particles are close, it means it is high density material. If the particles are far away, it means there is low density. So when particles are close to each other, particles collide with each other. So due to that collision, friction occurs. And the result of friction is release of energy, the release of heat. So when there is high density, increase in density, it leads to increase in temperature. increase in temperature. And due to differentiated temperature, material inside started getting separating according to their density. ओके, कॉमन सेंस है, टेल मी, जो हैवी मटेरियल होंगे वेयर विल दे गो? जो भारी चीज है वो तो नीचे की तरफ ही जाएगी, दब जाएगी नीचे ना. तो हैवी मटेरियल या फिर मटेरियल विद हाई डेंसिटी दे सिंक्स टुवर्ड्स द सेंटर. मटेरियल्स विद हाई डेंसिटी sink towards the center. And that is why you still can observe the center of Earth, that is core, is made up of heavy materials, Nife, nickel and iron. And the material with low density, it tends to come closer to the surface. Okay, and when that material started to solidify because temperature was decreasing, as you go upward towards the surface from the center, temperature decreases, and due to decrease in temperature, that material started solidifying. वो सॉलिडिफाई होना शुरू हो गया, एंड दैट सॉलिडिफाई फॉर्म वो ये हम आज देख रहे हैं, दैट इज क्रस्ट, जिसके ऊपर हम चल पा रहे हैं, दैट इज लिथोस्फीयर. तो दिस वाज ऑल अबाउट origin of lithosphere. Now atmosphere and hydrosphere. The evolution of atmosphere and hydrosphere are interlinked. There are 3 stages. As we have discussed, the atmosphere was very thin in the earlier time, in the primordial stage. So the first stage include removal of that thin atmosphere by solar flames. The flames from sun, जो वहां से solar flames आई, उनकी वजह से जो earlier thin atmosphere था, that got removed. So stage first. Removal of primordial atmosphere, thin atmosphere. Now Earth had no atmosphere. So with the passage of time, the surface of Earth, या आप कह सकते हो the heat, the hot interior of Earth started contributing in the formation of atmosphere by releasing various gases. So the gas starting releasing from the surface, from the lithosphere. And what were those gases? Nitrogen, carbon dioxide, ammonia. Okay, all these were the initial gases released from the surface of the Earth. And outpouring of these gases is called, it is a process. The process of outpouring of these gases from lithosphere is called degassing. So in short, आप इतना याद रखो that hot interior of Earth contributed in the evolution of early atmosphere. And one important, water vapor. So when these gases reached in upper layers, the water vapor started condensing. You know the process of condensation, evaporation, condensation. After condensation, precipitation take place. So the water vapor released from the volcanic activities on the lithosphere, because all the gases were releasing through the volcanoes or from the lithosphere. So water vapor that was released from lithosphere or from the volcanoes start getting condensing due to fall in temperature. Condensation of water vapor due to fall in temperature. And one more thing happened. The CO2 which is responsible for keeping the earth warm, that mixed with water drop on the surface. Now because of decrease in CO2 in the decreased, because it was CO2 that was keeping the atmosphere warm, and due to decrease in CO2, temperature further decreased, condensation further place, and the rain which was falling on the surface that got filled in depressions, जो कि लिथोस्फीयर के ऊपर पहले से ही बड़े बड़े गड्ढे बने हुए थे, उनके अंदर जो प्रेसिपिटेशन हुई वो पानी भर गया, एंड दोज डिप्रेशंस बिकेम ओशियंस. लिसन. Okay, so due to decrease in concentration of CO2, further condensation took place, more precipitation took place, and the water that fell on surface got filled in the depression that were already existing. Listen, last, जो पैसिफिक ओशियन है एंड द अटलांटिक ओशियन, हमको लगता है वो हमेशा से ओशियन ही है, लेकिन अगर हम उसका पानी निकाल दें, बिल्कुल उसका सारा पानी निकाल दें, तो उसकी भी कोई ना कोई सरफेस तो है ही. तो अगर वो पानी होता ही नहीं तो हम क्या देख सकते हैं? पूरी जमीन एक बंजर रूप में और ये सब हमें गड्ढे के रूप में दिखाई देते हैं. अटलांटिक ओशियन, पैसिफिक ओशियन, इंडियन ओशियन, अंटार्कटिक, ये सब गड्ढे होते हैं. इनके अंदर पानी भर गया ड्यू टू दिस प्रोसेसेस. अंडरस्टूड? So this was how initial oceans were formed. But in this atmosphere, there was very little free oxygen. The water was full of carbon dioxide, and the composition of nitrogen and all these things were very high. But the concentration of oxygen was not up to the limit that is required for the survival of human beings. So as we know, life originated on Earth 3,800 million years ago. But photosynthesis, that is photosynthesis by the plants, or we can say early plants, they originated in water. (25 to 30) 100 million years ago. So in the initial oceans, the concentration of CO2 was very high. But when the early plants, early vegetation occurred in oceans, after that photosynthesis took place. So what happens in photosynthesis? In the process of photosynthesis, plants release oxygen. They take CO2 and release oxygen. So CO2 was already in abundance in oceans. So there was no shortage of CO2 in water. So due to excess of CO2 in water, those plants could flourish. And after the flourishment of those plants, the photosynthesis took place more rapidly and they released more oxygen. And by 20,100 millions years ago, the water was completely saturated with oxygen. $2,000 या फिर आप कह लो 2000 million year ago, water was completely saturated with oxygen, and after that, that oxygen started releasing in atmosphere from water, and with the passage of time, concentration of oxygen started increase in atmosphere, and this is how your current atmosphere, in which there is around 21% oxygen, 78% nitrogen, your atmosphere was evolved. So we have studied evolution of Earth, evolution of lithosphere, evolution of hydrosphere, and atmosphere are interlinked. And through these processes, eventually the Earth that we can see now evolved. Thank you and have a nice day.